Hi everyone. Thank you for having me here at BSides Lisbon. I'm going to present a talk around MISP, Cortex and DeHive. And my name is Saâd Kadhi, as Bruno mentioned, and I'm the leader of the TheHive project. So to start our talk, we'll begin with an overview. About the TheHive project, basically, I've built the project with other people for two reasons. The first reason is because we work at a computer security incident response team. I lead one at a large financial organization. And since I've started working in this field 10 years ago, I have been kind of getting like mad because I was thrown under a large number of security events that keeps growing on and on. And at the time, I didn't have the right tools in order to cope with that massive amounts of security events, including, of course, false positives, and try to drive down the time to detect and react. So as a token of appreciation to the community, which helped the other founders of the TheHive project do their work, thanks to the large set of open source tools out there, we created the TheHive in Cortex, which I'm going to speak about shortly. So how we set up in order to drive the time to react and detect, we decided to try to explore ways in order to collect as quickly as possible in as cleanly as possible alerts and events from different sources. Try to automate all the tedious tasks an incident handler or an analyst do on a daily basis. For example, analyzing malware, analyzing URLs, and things like that. Because a lot of the work that a security analyst does might involve copying and pasting from different interfaces and scripts. For example, if, let's say, someone reports a suspicious email to me, and of course there will be like back and forth, can you please send me the full headers, for example, of your email? And then I find a link in the body of the email. I take that link, I copy it, then I go maybe to VirusTotal, and I paste it there. But maybe when I do that, I should have thought that I should not be doing that, because at the time I received the suspicious email, I'm not sure it's a targeted attack. So maybe by pasting, I would say sending the file to VirusTotal or sending the link to VirusTotal, I'm leaking some data that attackers might be observing. So I'm giving them, like I would say, tips that I have found them in my network. And also, as I've seen this field grow, I've realized that there is no, I would say, it's not a one-man or one-woman show. It's a large skill set involving different security analysts from different perspectives, reverse engineers, malware analysts, incident responders, and so on. So they need to collaborate all together. So we created tools to help with cyber threat intelligence, I would say like collection, but I would say in TheHive and Cortex, this is just a little part of those tools because we rely on the de facto standard for that, which is MISP. Our core, I would say, value would be rather in incident response and digital forensics, as we'll see later in some use cases. So created TheHive and Cortex. We also provide a set of libraries I'm going to mention later, and also what I call feeders, which basically take some alerts from some source, for example, from your IDS or from your CM, and then inject them to TheHive. And there is one special feeder called Synapse, which I'm going to talk about later. Currently, the TheHive core team is 6 members, baked with a large CSIRT community. We are not commercial shop, of course, so we don't really track who is using our software. But we can count more or less more than 50 large and semi-large organizations throughout the world that are using actively either the TheHive Cortex and or both. So we created TheHive internally in our team in October 2014, and we kept refining it, using it on a daily basis. We had 12 analysts using it, and once it was good enough for us and decided to share it with the community, we didn't want like just a proof of concept and call for help. We wanted something really stable that works for us on a daily basis, and once we were satisfied with it, we released it on November 2016 under a EGPL v3 license as MISP. And a few months later, we released Cortex, which is an analysis engine which was first embedded in TheHive, and we extracted from that for reasons I'm going to mention later. If we take the SANS 6 steps process, which could be familiar to, I would say, even junior incident handlers, so you have the basic step, which you always have, like preparing your team to deal with incident response in digital forensics. Then move on to detection and identification. From that to containment, eradication, recovery to get back to business, and then lessons learned, which often than not is something that we forego because like we are busy or we don't want to document things properly. So if we take those 6 steps process, I would say that TheHive more or less covers all of them. Because it allows, like I would say, the team to, once they receive an alert right in TheHive, to try to like identify it, leveraging by that Cortex. Also like contain things. For example, you can use the Cortex responders to perform actions, like for example, block this IP address, which is malicious, at the proxy level. Or open this ticket in Jira to ask the IT team or the network team, for example, to do some action. And then you can also go as, I would say, as far as eradication, but I would want to recommend that through automated ways, at least not if you don't know what you're exactly doing, again, through Cortex responders. And move on maybe to recovery by, again, using the responders to, I would say, like, unblock some IP or some user account and things like that. So Cortex is an analysis and response engine. It covers the 4 steps from detection, I would say, identification, up to more or less recovery. While MISP is used for IOC storage, indicators of compromise, but also with sharing with your constituency and with your other peers and partners. So, in a nutshell, TheHive is what we call a SIRP, a Security Incident Response Platform. For those who fancy buzzwords, Gartner came up a few, maybe months or years ago with a new fancy word for that, like security orchestration, automation, and response. Well, so it allows you to collaborate in real time. It has like a Twitter-like feed, which you can monitor to see what's happening in the platform. And just by, for example, if you see like in your Twitter feed, like a new task that has been created, just by clicking on it, it belongs to you. You can start working on it, and the others will see immediately that you are the one who is, for example, doing reverse engineering malware. It has also fully customizable dashboards to allow you to track activities. For example, you can say, what are the, I would say, top 10 types of IOCs I'm ingesting? Am I doing something with them? Do I have the tools to do something with them? Or you can, for example, say, what is, I would say, regarding my SLAs to my constituency, what is the maximum time I'm taking to deal with a specific cases, like, let's say, phishing cases? Again, what are my top 10 used analyzers? For example, let's say VirusTotal is among them. So that will allow me to say, okay, so next month maybe I need to add more money because I'm exploding my VirusTotal quota. It by itself, I would say, it's more or less useful, but it's better to use it in combination with Cortex and MISP. So Cortex would be used by TheHive for analyzing at scale observables of different natures. For example, if you say like, hey, take those 100 URLs, submit them to virus total, passive total, or take those 100 files, send them to both Cuckoo sandbox and Joe sandbox at the same time. It also allows you to do response. For example, as I said, block this IP address at the proxy level, open this ticket in the IT ticketing system, and so on. It can also leverage MISP for CTI functions. We will cover that later. It has multiple authentication methods, like you can mix and match LDAP, AD, OAuth2, API keys, TLS certificates, and so on. It has also webhook support for automation, and just like a few of the main features of the platform. As for Cortex, as I said earlier, analysis, response. Currently, it has 101 analyzers. So when we released it back in February 2017, we supplied 16. And almost all the others have been created by the community and contributed to it. So they are all open source. But of course, like I would say the virus total analyzer, which is open source, requires a subscription to the commercial service. Some are completely like free, like file info, which is kind of a, I would say, file static analysis analyzer. It has several models, for example, OLI tools and things like that. It's completely free. To develop the analyzers, you could either go the easy way using Python, because we provide a library to ease up that, or you can go the hard way and choose another language. For example, Rostelecom in Russia created, I would say, about 10 analyzers in the Go language. And TheHive can plug itself with multiple Cortex instances. For example, you can have one Cortex instance within your network for your internal services, and maybe interacted with a few external ones, like passive total, virus total, doing Yara analysis and things like that. And you have another Cortex instance seated on the outside, which is dealing with your sandbox, because you don't want to, I would say, detonate malware that can get offhand and escape from the sandbox, then maybe impact Cortex, and which might result in impacting your TheHive instance and your internal network. So it's like for OPSEC, operational security reason, you have like two Cortex instances. And you can Cortex can leverage MISP for additional analysis possibilities. For example, it can query multiple MISP instances to say, hey, do you have this IP address? And if you have the IP address, can you give me the event which it contains, that contains that IP address? And of course, I think many people know MISP or use MISP. So in my opinion, it's the de facto standard for thread sharing. And also, it's the opinion of some, I would say, big names like Forrester in their Q3 report of this year. They have compared MISP with different commercial tips like Eclectic IQ, Anomaly, Threat Quotient, and so on. And the adoption, they found out that the adoption of MISP is by very, very large in comparison to the commercial alternatives. And moreover, the support is quite good in comparison to the commercial alternatives. So they said, like, yeah, if you don't fear FOSS, you should use MISP. So it allows you to collect your threat intelligence, whatever you put behind that word. Let's not get into the debate now. Sanitize the IOCs, for example, you get, and disseminate them through like sharing to multiple MISP instances, but also to different other tools, such as TheHive. It allows you also internally to do correlation, and basically we use it when you use the trio of TheHive Cortex and MISP, we use it to store our IOCs. It supports tagging, galaxies, objects, taxonomy such as ATAC, and much more. It can be also highly automated. And as I said earlier, TheHive can import events from MISP, export event from MISP, and can do both at the same time. It can, for example, import from 2, export to 3, and I would say do both on 2 others. And it's also tightly integrated with Cortex. For example, if you are only a MISP shop, you don't care about doing incident response, you're just weeding through your you're like a threat analyst, something like that, and you're only worrying about enrichment and things like that, you can still use MISP and Cortex. So you can call Cortex from MISP and enrich the data set. From an architecture point of view, so both TheHive and Cortex use more or less the same stack. So the backend is written in Scala using Akka and Play framework. And the front end of both Cortex and TheHive are just basically making RESTful API calls to the backend. And currently we use Elasticsearch for storage on both TheHive and Cortex, but we have plans to move away from that for serious limitations we have encountered down the road with Elasticsearch. We are considering moving, I would say, around Q2 of next year to GraphDB. The analyzers and responders are usually written in Python, but again, you can use any programming language that is supported by Linux. One nifty feature of Cortex, it has airbag or role-based access control. And in role-based access control, you could like have multiple organizations within your Cortex. You can have, for example, let's say I'm a large CSIRT. I have operations in North America. I have in Europe and in Asia. And I say, okay, I have my North American CSIRT, which has, let's say, a quota of VirStol. Like it can make 500 queries per day to VirStol. And for Asia, I can give them like 200, and for Europe, 300. And I can like, for each organization, I have my specific configuration. But I can also leverage caching. For example, I can say, if you receive the same request for the same observable, for the same analyzer, for example, someone trying to analyze an IP address in Asia using VirStol, and 1 minute later, someone from North America doing the same thing, you just serve them the report from the cache. If they don't need like a fresh data. So you can save up your money and your quotas. And it can be called, of course, from TheHive and from different tips and MISP. For example, if you are using a SERP called the Misto, which is a commercial alternative, it has already an integration with Cortex. So it can leverage Cortex to make queries in enrichment. And you can also, like, if you are still, you still like doing like, command line scripts and things like that, you can just call Cortex 4P, which is a Python library, and cook your own Python script in order to query Cortex and do response and analysis. And it has also a web UI, but the web UI is mostly used to configure things and to do quick assessments of observable. It's not really used for, I would say, at-scale production environment. As for the workflow, so everything in TheHive is a case. So an investigation equals a case. You can create a case out from scratch, but you can also create a case out of templates. You can have multiple templates that you can import and export from multiple TheHive instances. Let's take an example. You can have a phishing template, you have a mass spam campaign template, you can have a DDoS template, and so on. And you can create cases here or investigations out of alerts you receive directly in the platform, so either fed by alert feeders or directly from MISP as MISP events. Once you start a case, you create tasks. For example, you have a task called identification, a task communication with my constituency, a task reverse engineering the malware, a task, I would say, recovery or lessons learned and so on. You can group those tasks with tasks group. So for example, let's say I have a group called communication, and I have a task communication, internal communication, another task external communication, and so on. And a case can contain 0 or multiple observables, so observable, IP address, URL, file, hash, and so on, that you can analyze using 101 analyzers, and shortly, in a few weeks more, through Cortex. And you can customize, I would say, the analyze results using report templates. So we supply report templates for those 101 analyzers, but you can customize your own. They're just like Bootstrap code that you can change to your liking. And basically, report templates are of two sorts. You have the long report. We will show an example shortly, and a short report. So the short report just gives you, I would say, an idea. It's like a quick assessment, and it has a color code like red, dangerous, blue, it's informational, and etc. And again, while analyzers are specific to observable, so for analyzing observables, responders can be applied at any level. So at the alert level, at the case level, at the task level, but also at the observable level. So imagine, for example, in a task you write something like block IP address, blah, blah, blah. And you have a responder that it can be applied to a task log. So you just click on the responder and it will understand what is within the task log, and it will perform the action and report back to you whether it is successful or not. We can also have, for example, a responder at the alert level. So you receive an alert, like, for example, a user reported a suspicious email. You preview the alert. Oh, shoot, another scam. So you don't want to create a case for it or something. Just say to the user, ignore it. So you don't have to write anything. You just like click on the bottom of the responder, and it will respond automatically to the user. So like, hey, forget about me today. It's just a scam. Don't bother me. So as for the integration of the tree, you can think about that as a triangle. So on top you have TheHive, which will receive alerts from different sources. For example, you have cyber threat intelligence providers, SIEMs, emails, as I said, suspicious emails coming from your constituency. For example, in our team, we have developed a plugin in Outlook where users can just, like, when they spot a suspicious email, they highlight the email, click on the button send that to a mailbox where we have a script that scraps the mailbox, a Python script, and any new email, it will like package it as an alert and send it to TheHive. So from there, we can do our analysis and everything, respond in TheHive, and just click on our responder to respond back to the user. So we don't have even to see emails again. We do everything from TheHive. And once you have, like, I would say, the alerts and you start doing cases analysis, so you can, as I said, leverage Cortex to do your analysis on a respond. And if you have MISP, you can plug your MISP or any MISP you have access to with TheHive to receive events and export also cases to share back with your peers and partners. MISP and Cortex can talk to each other. So Cortex can analyze, like has analyzers to query MISP. And MISP can leverage also Cortex to enrich the data set. One feature we had in Cortex 1 that is not currently, we removed it from Cortex 2 because there was almost no one using it. Cortex had the ability to use all the MISP extension modules. So that's we have dropped that from Cortex 2, but if the community wants it again, we can put it back. One special mention of signups. So as I said, like there are feeders. There are some open source feeders out there. For example, there is one we created called Digital Shadows to TH, which if you are a Digital Shadows customer, you can just plug your incident, like a threat intelligence incident from Digital Shadows right into TheHive. If you are a FireEye Eyesight customer, you can do as well. It's Leonardo Cert in Italy, who created another feeder for that as well. There is ZeroFox2th and others. But we have a special, I would say, feeder called Synapse, which is kind of a meta feeder. The idea, it's provided by us, is we'd like people to, like, we provided a framework to Cortex to ease up development of analyzers. That's why we have 101 today. And we are trying to do the same with alert feeders. So in Synapse, you can just design, I would say, your input. Today it supports Exchange in Office 365, but also QRadar as a SIP. And so you add your inputs, you have a workflow designed within Synapse to say, okay, when I get this, I do that. Like If this, then that. And then it has the connector to TheHive in order to feed it alerts and things like that. As for events, so when you receive events from MISP, they will show up in the alerts pane of TheHive like this. I hope you can read a bit the slides, but I will share them later publicly. So you see them like this, and you have several icons on the right-hand side where you can preview the alerts and decide what to do with them. So here, for example, we preview one. We have the description. We have the different MISP tags, the different type of observables that are within the alert. And before importing it, we have to create a case template. So, for example, here we have a case template. Probably you can try to read it. Call it MISP event with different tasks. So, for example, in different groups, we have identification group, call it containing a task, call it initial assessment. Then in-depth analysis. We have another task group called communication, internal, then peers and partners, and other, and so on. You can add like severity, TLP, PAP, which is permissible action protocol. So permissible action protocol is basically what you are allowed to do or not when doing your investigation. So example, you are suspecting you are under the attack by advanced threat actor. You shouldn't be doing action on your network that would tip them off that you are looking after them. So you just do passive actions. So you can set the PAP as red. It has the same color code as TLP, traffic light protocol. And basically, if you design things well on your analyzers and responders, they will not work if you are doing something that is active on your network. So, hey, this action is only for PAP amber and below. You are in PAP red, you cannot allow do that. TLP is also important for analyzers. For example, you can set VirusTotal file submission to TLP green. And if you have an observable that's TLP amber, so you should not be sharing it publicly. So if you submit it to VirusTotal, the attacker and anyone watching VirusTotal will see that you have shared that. So they might change the tools, tactics, and procedures. So basically, if you have the VirusTotal analyzer set to TLP green, when you try to run it on a TLP amber observable, it will not work. So it's like a safeguard. So once we have created your MISP event template, once you import the alert, it will just give you import alert as and the default template for MISP. But you can override that to your liking. So once we have imported the alert, it becomes a case like this with the different tasks and so on. I have like the observables, 41 in this example, 10 different tasks I need to work on. And you can see on the right side the real-time stream, which is like the Twitter feed. You can just open like this feed in a specific window, so you don't look to TheHive anymore, and just have this little window in your big screen. And whenever new things happening, they will, like, as in Twitter, you see a timeline, and you say, hey, this is a task for, I would say, I don't know, analyzing this malware. I am free. I'm not doing anything now, so I just click on it to start the task, and everyone will see that. So that's to ease up collaboration. And you can see like several buttons up there. Like, for example, you can merge cases. For example, you start 2 investigations, and down the road, you realize it's relevant to the same thing. So you just take case 1, case 2, and merge them as a new case to collaborate. You can like share those cases. So like I share one because it's already coming from a MISP instance. You can share it to other MISP instances as well. So the counter will increase. And you have the responders that apply at the case level. So here, just a view of the observables. So you can like have statistics and filters and so on. For example, here we have, so someone on the MISP instance I'm connected to has updated an event with new things. And I've already started working in the case. So you don't have to do anything. You see that little view there, icon there. So they have added new observables. So you will receive them automatically in your case. You don't have to do anything. So once I have my observables, I can move on to analysis. For example, here I have an IP address, and I have the little I there, meaning I've already seen it in a different case. So I just select the analyzers I want to run to. For example, here on DShield lookup, and I would also have virus total get report. And then I can see, like, in the Twitter feed, Twitter-like feed, that I have started the analysis. And once the job has finished, it will show up there. And I see all the mini reports showing up. Look here, the DShield score is very high. But VT does not know anything about it. So when I go to the, I would say, long report of DShield, I can see there is show observables because it has found new observables. So if I go there, I see there is an autonomous system. I saw an email address. So I just click on that and import them again in my case. So it's like enrichment, pivoting, and so on. Again, the interaction between MISP and TheHive is like, as I said, whenever you created a case out of a MISP event, and that MISP event keeps being updated, you would receive the new attributes in the MISP event automatically in your case. By default, every 1 hour, but you can adjust that. And for example, down the road, you are working on your case and you discover new indicators of compromise. You say, okay, that's cool. Let me share them back with the original order of the MISP event. As I would say, token of gratitude and a collaboration between teams in incident response. So probably you don't have the rights to write to that MISP event because you are not in the same organization as the other end. So that's not a problem for TheHive. It will figure out that and it will create an extended event. So extended events are a nifty feature of MISP which allows you to extend an event out of an existing one by adding new data to it, even if the original event does not belong to you. So here in the example, for example, I was analyzing on that case, and I found a new domain name that is highly suspicious. So analyzing it using FortiGuard. It tells me it's a malicious website, and also there are at least 3 related URLs in virus total. So I say like that here, I can say, okay, nifty. I tag it as IOC, so it's an indicator of compromise, and I share it to MISP. So I export it to this MISP instance. I see that it has been successful. And from there, I can see that now I have 2 events. So the bottom one is the original one, belonging to the circle organization, and I don't have write rights on that organization. And the new one I have created, which is on top. And it's basically, if I look up at that event, I see it's here, it extends event 485. And if I look at it again, I can see that it has only one indicator of compromise or attribute. It's the domain name I was investigating. So it extends the original event. And again, this is very important. So let's take again that example of someone contributing a MISP event. It contains 120 attributes. They are not in the same organization as me. So I decide, hey, that's cool. Let me create a case, start investigating. So when I create a case, I have 120 observables. I move on to incident response. And then the original, I would say, order, add 30 new attributes. From there, BIM, I have automatically 30 new observables in my TheHive case. I do incident response, and I find 5 observables from my side. So this is mine, I would say. And I would like to share them back. So when I try to share them back, they receive nothing on the other end because they are only observers. They are not IOCs. But when I have IOCs here, 3, and I try to share, so they will receive 3 new attributes. So TheHive will only share IOCs. It won't share, for example, observables like your internal email addresses. So it doesn't make sense. It might even like be bad from a confidentiality point of view. And there is, of course, more to it. So TheHive can monitor the connection health to all the MISP and Cortex instances it's connected with. So it would tell you if one connection with a MISP instance is failing. It even try to authenticate there to test the connectivity. Right? It does the same for Cortex. And you can have several filters to tailor your integration with MISP. Because more often than not, if you begin in this field, you say, hey, let me start with finding some MISP instance out there, public one or things like that. One famous one is the circle MISP instance. And if you have ever tried to connect to look at the MISP instance of circle, it is full of garbage. And when you start doing that in TheHive, you end up like when you first synchronize the MISP circle instance with TheHive, you might end up on 100,000 events, and you will be swamped. You call it a day, and you abandon cybersecurity, and you go like grow potatoes. So to avoid that, we have put a different set of filters. So you can decide you can only import MISP events that have like 10 attributes, or the MISP event that are dated less than 1 month. Or you can even tag whitelist. So for example, anything that contains that, I will include. You can also blacklist organizations. So for example, let's say those organizations are just contributing rubbish. So I just like ignore them altogether. And so on. So the upcoming features is, so in Q2 2019, as I said, we are moving away from Elasticsearch to GraphDB. We will also share sightings with MISP, and we will add support for MISP objects as well. And in 4.3, so this is like a roadmap. I haven't signed it with my blog. We will add taxonomy such as ATAC support. So to try the trio, it's pretty easy. You can like try them in combination because we now provide a combined training VM containing MISP, TheHive, and Cortex. Everything is connected. Or you can try them separately. And there is additional software from from the Hive project and MISP project. So, for example, Ale from the Circle lets you like it's analysis information leak framework lets you submit whenever you detect something, send it to the Hive automatically. We provide a set of libraries to integrate with interact with the RESTful API of both the Hive and Cortex. There is alert feeders, as I've already mentioned. And from the community, there are, like, for example, an email feeder provided by Xavier Mertens from the Science ISC. There is a simple script to interact to bridge QRadar with the Hive if you don't want to use Synapse. And as I said, Rose Telecom has a set of analyzers written in Go. So that's it for me. Thank you for attention. Do you have, I don't know if you have time for questions? Any question, maybe? No? Okay, thank you.